Now we're going to talk about the template design pattern, and this design pattern looks something like this schematically. And here you have a base class which defines a template method. So there's a base class that defines a template method. In this case, the template method might be called Go, for example. And I'm going to specify methods to call in the inheriting class inside the Go method. Let me tell you what that means. The idea is, for example, say that you have you're creating a robot, and the template, various different types of robots that can construct cars, can bake cookies, and so forth, things like that. But they all have the same general template. When you execute the Go method, you have the robots start, they get the parts they need, they assemble the parts they need, they test the results, and then they stop. So that might be a robot's template. So all robots, whether or not they are automotive robots or cookie robots or whatever, start, get the parts they need, assemble the parts they need, they test them, they stop. And so this is a template for the robot actions. This is just an example using robots to illustrate the template design pattern, and you have these various methods that are called in order, and those methods are implemented by the inheriting class. So the inheriting class will support or override the get parts, the assemble, the test method, and so forth, for example. And that way, you can use this base class as the base class for a number of robots, and whether or not they construct cars or cookies is immaterial. They have the same basic methods, chain of command methods in the template method. So in other words, the same basic actions are performed in the templates, whether or not the robot constructs cars or constructs cookies or so forth. That's the idea. You have a base class and you have a template that lists the actions you want to execute, and then you inherit from the base class, and the inheriting class is what actually implements the methods, customizing them as appropriate for the type of robot you're actually creating. So the inheriting class could be an automotive robot, for example, where getting parts gets the parts for a car, assembling them assembles them, and testing them tests the car. Or the inheriting class could be a type of cookie robot, for example, that gets the parts, it gets flour and sugar and so forth, assembles them, bakes the cookies, and tests them by seeing how they taste and so forth, that kind of thing. So the idea behind a template is that you have the same actions, start, get parts, for example, assemble, same list of actions that you execute in a template method called Go here, and then it's up to the inheriting class to actually implement those methods. So the template is the same for the two different classes, the automotive robots and the cookie robots, but the actual implementation differs when you inherit from that class. When you inherit from the base class, the template class, which is this, when you inherit from that, the actual implementation is different. So this is valuable when you have cases where you have a shared set of actions, and, for example, start, get parts, assemble, over very many different types of inheriting classes. You can use this template then as in a template method to construct a base class from which you inherit, and when you inherit that base class, those actions are performed in sequence, but the actual details of what those methods do is up to the inheriting class. So let's take a look at an example in code to see how this works. Creating the automotive robot, for example, and a cookie baking robot, and see how that works coming up in code next.